Let's try to identify some horizontal asymptotes. Well, our strategy is to compare degrees on the numerator and degrees on the denominator. Well, the degree of the denominator is to the fourth, and the degree of the numerator is to the second. So here we have a scenario where the degree of the denominator is greater than the degree of the numerator. Then we can claim that we're going to have a horizontal asymptote at the line y equals 0. So let's just graph that. It's pretty much the x-axis. Well, let's graph this function and let's see if that is true. So here we have the given rational function. Now let's graph the horizontal line y equals 0. So we are right. Notice that if I keep moving my function to the right, my function stays at the value y equals 0. Not exactly at y equals 0, but it is approaching that value. It doesn't exactly get to 0. And the same goes if we move to the left. My function stays very close to the value of y equals 0. We can claim that that is a horizontal asymptote. Now let me just address one small misconception. It is okay for us to intersect the horizontal asymptote. It is not okay for vertical, but for horizontal, it could happen. Because we are looking at the behavior as we move infinitely to the right and infinitely to the left. Now let's take a look at another example. So we have the same objective. Let's try to identify horizontal asymptotes. We will have the same strategy. Let's compare the degree of the numerator and denominator. But within this rational function, the numerator, it has a degree of 4. And the denominator, it also has a degree of 4. Well, in this specific scenario, the degree of the numerator is the same as the degree of the denominator. Then we can conclude that we're going to have a horizontal asymptote at the line y equals the leading coefficient on the numerator, which is 3, divided by the leading coefficient of the denominator, which is 2. So let's say that here we have 3 divided by 2, so we should expect to have some kind of horizontal asymptote at this specific location. Let's graph this function and let's confirm this result. So here we have our function, and now let's draw the horizontal line at 3 divided by 2. This does look correct. As I look at the behavior of this function going to positive infinity, notice that it stays on the horizontal line of 3 divided by 2. And the same goes as I keep moving towards negative infinity. My function stays at this line of 3 over 2. So we have satisfied the condition of a horizontal line. The behavior as you move infinitely to the left and infinitely to the right. Now let's look at our last example. Let's identify any horizontal asymptotes. Well, let's compare the degree of the numerator and denominator. The degree of the numerator is of a value of 7. The degree of the denominator, it is of a value of 4. Well, here we have the situation where the degree of the numerator is greater than the degree of the denominator. So we can say that we have no horizontal asymptote. Because here our function is going to either increase or decrease without a bound. Let's confirm that. Let's look at the graph of this function. And when we graph our function, we can see this behavior. As we're moving to the left, we are going towards positive infinity. And as we're moving to the right, we're actually going towards negative infinity. Our function, it is not approaching any value as we move left or right. Therefore, we do not have a horizontal asymptote. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.